All right, good afternoon, all students here. All these are from 4 students here. This is Tuesday. Today is Tuesday, so it's Tuesday from 4 group here. Welcome back, everyone here. Everyone are doing fine outside, right? At home, staying home, so very happy and very safe. Everyone at home, huh? Okay. So I start sharing the paper with you where we stopped last week. Okay, we continue from where we stopped last week. Okay. One moment now. Okay, our last lesson was in this Manmix satellite, correct? Not Manmix satellite. In Bahasa, we say satellite buatan manusia lah. Okay, actually what do you understand about Manmix satellite? What is Manmix satellite actually? You know or not?
Yes.
Can you tell me what is Manmix satellite actually? What is that?
We all make the satellite and put at the Earth, at the atmosphere there.
For what purpose one? Can you tell me?
For GPS, for telecommunication.
For GPS, for communication, for weather forecast or this kind of thing now, okay? For live telecast of this event happen in the world, okay? Television live show, you need the satellite. Okay, in fact, in the sky there, up into the sky there actually got thousands of satellites. Okay, I can say that every country they have their own satellite in the sky. Okay, the biggest country the richest country they have more satellite, right? Okay, so the satellite actually now is become very, very important, especially in the near this 10 years lah. Satellite is very important already, become too important in our life lah, I will say now. That's why we need to study man-made satellite now. Okay, our last lesson we see this man-made satellite, right? Okay, so when you look at this diagram, this is our Earth. In the sky there, you have the satellite, right? This satellite can orbit, follow this circle must have certain criteria one, You cannot just take a rocket, lift the satellite up here, then you expect the satellite to stay here forever. No, it wouldn't happen one, the satellite will fall back one. But what I want to ask you all how to make this satellite stay here to keep oscillating the Earth for 10 years, 20 years, you must have something, I know everyone knows one, use a rocket to carry the satellite up into the sky, into a certain height. Then after that, the rocket has to lift the satellite there. So the satellite will be staying there, keep rotating for long, long time one, So how this satellite can stay here to rotate? How, you know or not? Soon, do you know?
Force,
Yes, to have centripetal force, meaning that the satellite must rotate, isn't it? The satellite cannot stop here one. You have to rotate, right? It must rotate with a certain speed, must have a certain speed. The speed have to be calculated very accurate one, If you don't have the speed you cannot stay there. It will come back. It will drop. If the speed too fast, you cannot. So the scientists they have to do the accurate calculation what is the mass of the satellite, how far you want to put the satellite into the sky. So you must have this kind of speed. Okay. So because the speed is very important to maintain the satellite in this fixed orbit. Okay, for the years, for the time we want. So we have to calculate accurately You have to get the mass of the satellite, how big, what is the mass, how far you want to put it, right? Then only you can calculate the speed. Okay, now I want to ask you lah. To find the speed, we call it linear speed. This is the formula you have learned last week actually, linear speed. Linear speed is the speed of the satellite to circulate here so that it can stay here. Okay, forever. So the formula is square root gm divided by r. G is a constant, gravitational constant. Big M is the mass of the Earth, not mass of the satellite, it's mass of the Earth, divided by the R. R is the orbit radius, means this line, you see the diagram, from the center of the Earth to the satellite. R, we call it orbit radius. This formula very important. Why? Meaning that all the scientists, they use this formula to calculate one, you know. You just need to know the value of mass of the Earth, the value of the distance where you want to put this satellite up into the sky. Then you calculate. So you must have the speed lah. So you must push the satellite so that it will move with the speed you want. Okay. In fact, we have also discussed one calculation, right? Okay, this calculation, you see, we have discussed already, correct not? Tan Ken Hao, we have discussed already, correct not?
Yes.
Now you see here, I repeat one more time, you see the calculation, okay? GPS satellite, this is a GPS satellite. Calculate the satellite linear speed. They want you to find the speed law. If it is an altitude of 20,200 kilometers, okay, from here to here is 20,200 kilometers lah. Okay, so now we want to use this formula GM over the radius, orbit radius. The orbit radius must include the radius of the Earth plus 20,200. That's why you calculate the radius. So you take the radius of the Earth, this one, radius of the Earth, 6.3710 power plus 2.07 times 10 power 7, mean this one. This distance h is here, not including the radius of this one, you have to add the radius. So this one change to meter, you add 3 more zeros, so it become 2.02 times 10 power 7. So total up. So this is the value. This is the value for this orbit radius r. Okay, now you can put inside the formula. Okay, big G, the mass of the Earth and the distance. Okay, r plus h. So we calculate the here now. R plus h. Okay, and then you calculate, you get this speed. So meaning that for this satellite to stay here, you must achieve this speed, which is very, very high. 2.179 10 power 3 meter per second. This is 2,179 meter 1 second, you know, very fast. In 1 second, you must travel 2,179 meter, very fast. Then only the satellite can remain here, can stay in this orbit and then send information for us lah. So you have to rotate very fast. Okay. So remember that this is called linear speed. Okay. Linear speed is the speed required by the satellite to remain in the orbit, rotating in the orbit. Okay. All right. Now next. What will happen to the satellite if the linear speed in the satellite less than the required speed? I told you already, right? Less than. So what will happen? Now you see, the satellite will fall to lower orbit. So it will come down, it will fall to the lower orbit and continue to revolve towards the Earth until it enters the atmosphere, which is no good. This is what we want. Once it enters the atmosphere, it will start to burn because of air resistance. So we don't want this to happen. So what happens is the satellite will fall to the lower orbit and continue to revolve towards the Earth until enter the atmosphere. Once it enter the atmosphere, it's the end of the world. Because when you have air, right, in the atmosphere, it will start to burn. When it start to burn means this satellite considered gone already, right? The movement of the satellite at the higher linear speed against the air resistance will generate heat and eventually causes the satellite to burn and then gone, finish. Okay, so please copy down the answer. This was what will happen when the speed, the linear speed is too low. Too low, it cannot stay, it will come down. It will come down slowly, and then burn. Burn, then finish, gone case. Winnie and Joel, understand why two of you together, Winnie and Joel? What happened to you, both of you? Winnie, Joel?
Yes, understand.
Both of you understand. You're using the same computer, both of you.
Yes.
Yeah, whose house? Winnie's house or Joel's house?
Winnie.
Winnie's house. So Joel went to your place now. You stay together one way?
Yes, teacher.
Oh, you stay together one okay, now only I know you stay together one. Okay, come. This one finished already, copy already the answer. Okay, there's more to study, this Manmix satellite is very important. Lai Wei Hong finish or not? Lim Wei Hong finish copy. Jian Zhi finish copy or not? Okay, finish. Okay, come. Let me ask one more. Christine, have you finished copy? Christine? Christine, finish or not?
Yes.
Okay, finish. Okay, come. We move on to the next one. Next one, okay. Also something to do with satellite. Compare between, okay, please highlight. There are two types of satellite, geostationary. This is the first one. Geostationary satellite. Another one is non-geostationary. Non-geostationary. There are two types of satellite in the sky, okay? So remember the name. Geostationary. Another one is non-geostationary satellite. So now we want to see one by one. Okay, what is the meaning of geostationary satellite? What is the meaning of non-geostationary satellite? Okay, come, let me say very brief to you first, so you have the idea first. Okay, if geostationary satellite means you always see one, always see up in the sky one. You can always see, he never move away from you one, That is called geostationary. Why? Why it never move away from you? Because our Earth is rotating every time our Earth one day make one round one, isn't it? Okay, cell rotation the Earth also rotate one, one day make one round. Then this satellite follow the Earth to rotate That's why you always see. Let's say the satellite is in the sky on top of Malaysia. So when the Earth turning, it will follow It follow. That's why always you can see the same satellite on your head, right? When you are using a telescope to see you always can see the same satellite. Okay, this satellite they are moving, but they are moving with the same speed of our Earth rotate. Our Earth also rotate, so the satellite also follow. So every time you see the same one. So this one is called geostationary satellite. It will follow the Earth to rotate one. Okay, follow to wherever you go, you see the same one. Okay, now highlight this one, write down the answer. Geostationary, first one is a satellite that move around the Earth at certain height. It will move around the Earth at certain height in the sky in a special orbit named geostationary Earth orbit, meaning that it will move around the Earth in a certain height in the sky. Okay, so in a special orbit, we call geostationary orbit, Earth orbit now. Okay, and they move around the Earth in the same direction as the direction of the Earth rotation on its axis. I told you just now, right? Earth also rotate, so the satellite also follow the Earth to rotate. That's why you always see the same satellite follow you. Huh? Move around the Earth in the same direction as the direction of the Earth rotation. 自转，地球有自转的 ，OK？ Earth's rotation on its axis. And orbital period is 24 hours. Like Earth lah. Earth make 1 round in 24 hours. 地球自转一个圈是24个小时。So this satellite also round the Earth 1 round in 24 hours. Same lah. So we say orbital period is 24 hours. That is the same as the periods of rotation of the Earth. Always above the same geographical location. I told you lah. Always above the same position now. If it is up in the Malaysian sky, you always see on top of Malaysia. It won't move away one, because our Earth turning, it also follow. Okay, so this is more important. This is called geostationary satellite. Okay, remember the name now. Okay, copy down the answer. Later on, I want you to memorize all this. The meaning is very important. Geostationary, non-geostationary satellite. Okay, come. Next one. Non-geostationary satellite. This is what? Now, a satellite that moves around the Earth at changing orbit height. This one you see, it's also rotate around the Earth, but changing orbit height means the height is different one, changing orbit height. Normally in a lower or higher orbit than the geostationary Earth orbit. Satellite move around the Earth at changing orbit height, okay? Normally in a lower or higher orbit than the geostationary orbit, okay? So meaning that this non-geostationary satellite means the orbit is changing one, not fixed one, Sometimes it go lower, sometimes it go higher, like that one. So it's called non-geostationary. The position are not fixed, no. The side keep changing the orbit now. Orbit height keep changing, so it's not fixed, Move around the Earth at changing orbit height. Normally in lower or in higher orbit than the geostationary orbit, Orbital period shorter. When it go lower, mean orbital period shorter than 24 hours, no? When it go higher, the orbital period is longer than 24 hours. So it can be shorter than 24 hours. It can be longer than 24 hours, okay? Then above different geographical location at different times. So meaning that this kind of satellite, you won't see all the time one. Sometimes you see in the sky in Malaysia, sometimes you never see because it keeps changing position. Okay? So you have these types of satellite one, Okay? This type of satellite, I tell you, is mainly for taking pictures. You see like Google Earth, you see Google Earth, right? You can have the pictures of the whole world, So how they're going to take the pictures of the whole world? They must they must not fix in the same country, they keep changing, no? Understand? Keep changing and go around the world. This kind of satellite is called non-stationary satellite, okay? That move around the Earth at changing orbit height, normally in a lower or higher orbit than the geostationary. Orbital period can be shorter and can be longer than 24 hours. Both different geographical location, no, at different times, okay? So remember that are not fixed one, Okay, now 2-3 minutes, I want you to memorize all this, Geostationary satellite, memorize it. After this, memorize non-geostationary satellite. Okay. Okay, start from now, 3 minutes from now. Okay, memorize it, read and memorize it. Okay, come on, start from now. Three minutes, okay, come on, please, Okay, 1 more minute. Okay, time's up now. When I call your name, so you just come out lah. Don't worry lah. Just try only, Okay. Cassandra, can you come out, please? Where are you, Cassandra?
Yes.
Can hear or not, Cassandra?
Yes, teacher.
Okay. Cassandra, can you tell me one thing you know about geostationary satellite? Just tell me anything you know about geostationary satellite.
Always above the sun geographical location.
Yes, correct. Always above the same geographical location. Now, why like that, Cassandra? Why always above the same location one? Why can be like that? Because the satellite actually moving one, they are moving. How come you can still at the same position? Cassandra, can you explain or not? I think some other student give answer already. Oh, Cassandra, now like that, I don't know. Try lah. Don't want to try, Cassandra. Okay, now never mind. Ask somebody else. Damsun, can you come up, please, Damsun?
Yes.
Damsun, can you explain why this satellite, geostationary satellite, always above the same geographical location one? Why always the same one? Why the location?
Because it moves around the Earth in the same direction, and the direction of the Earth rotates on its axis.
Very good now, Samson. You are really smart. Yes, correct. Because the Earth rotating, so the satellite also follow. When the satellite follow the Earth to rotate together means always at the same point lah. Understand now? Cassandra, do you understand now? Because the Earth rotating, so the satellite also follow. So it will follow lah. The side it will fix at the same position lah. Okay, all right. One more. Okay, one more. Now I want to call this who Xia Xingyin. Xia Xingyin. Can you come out, please? Xia, don't be shy. Come out, please.
Yes, teacher.
Very good. Xia Xingyin, tell me one more things about geostationary satellite. You know. Those who mentioned already, one don't say lah. Any more thing you want to talk about geostationary satellite? One more thing.
Orbital period is the same as the period of rotation of the Earth.
Yes, which is how many hours?
24.
Yes, correct. Thank you, Xia. The orbital period for this satellite is 24 hours. Same as Earth. Earth ring make 1 round 24 hours. So this satellite also follow also 24 hours. That's why you always see the same satellite in the sky. Okay. All right. Next one. You don't scared. I know you're very scared. When scared, I call your name. No need scared one. We are just playing only. Don't scared. Lu Wai Ting, are you around? Lu Wai Ting, can hear me or not? Oh, she cannot talk. She can type only. Okay, never mind. I find someone can talk one. Tan Kian Hao, this sure can talk one. Tan Kian Hao, where are you?
Yes.
Kian Hao, can you tell me
Yeah.
one thing about non-stationary satellite? What is that?
Orbital period is shorter or longer than 24 hours.
Yes, correct. The orbital period for this kind of satellite can be shorter than 24 or longer than 24 hours. Why? How can you explain why like that? Why can be shorter? Why can be shorter than 24 hours? Why can be longer than 24? Why?
Because its position is lower or higher at the geostationary Earth orbit.
Yes, correct. Very good. How? Thank you. Because this kind of satellite, the position not fixed one. Sometimes it go lower. When it go lower, right? So it's faster, so it's shorter than 24 hours. When it go higher, right? When it go higher, so the orbital period become longer than 24 hours. So it's not fixed one. Okay. So that was non-stationary satellite. Okay, enough already. Okay, everyone can come out. I know some of you going hide already, very scared. Now can come out. Okay, now similarity and characteristics. Now first similarity. The similarity orbit the Earth, both also orbiting the Earth. Okay, 这两个是它的共同点orbit the Earth, meaning that geostationary satellite, non-geostationary satellite also orbit the Earth one. Okay, and second similarity follow this formula. This formula is a linear speed of the satellite. It must follow this formula. V speed equal to square root gm over r. This formula obey or can be used for both satellite, and also this formula. This formula is to find the orbital period. Square root 4 pi square r cube over gm. This formula also you learn already, right? In Kepler's law. These two formula also similar to both types of satellite. Okay, so remember, no? Okay, 1 minute memorize the similarity. The two types of satellite similarities are what? 它们两种卫星的共同点是什么？背起来。1 minute very fast one. Okay, time's up. 1 minute. Kelly Tai, come out, please. Kelly. Kelly Tai, where are you? Don't hide already. Come out. Kelly, where are you? Kelly Tai?
Yes, sir.
Kelly, can you tell me one similarity between geostationary and non-geostationary satellite? One similarity.
Orbit the Earth.
Yes, very short, right? Can you give one more? One more similarity between the two types of satellite. One more similarity is what? See the screen now. One more similarity is what? Kelly, don't go away, not finished yet.
I don't know.
Nah, that is the answer is already there, why you say don't know? Okay, now mind. Then ask another one. Tai Hong. Tai Hong, come out, please. Tai Hong. Tai Hong. Okay, can you tell me one more similarity between geostationary and non-geostationary? One more similarity. 还有什么共同点？
velocity.
Yeah, follow the formula lah. Both of them follow the velocity formula. Okay. And also follow the formula of orbital period. The two formula also apply on both types of satellite. Okay, Okay, now we go to differences. Differences got a lot. You go one by one. 这边很多东西要背哦。Okay, differences first one is directions of motion. 它走的方向。Geostationary, right? Direction same as the direction of Earth rotation. 跟地球的旋转方向一样。Okay? Non-geostationary, direction of motion need not be the same. Not necessarily be the same one, as the direction of Earth rotation. Need not be the same. Meaning that for geostationary satellite 它的 rotation 它旋转的方向一定要跟地球一样 same as the directions of Earth rotation. But for this non-geostationary can be same, can be different, because it say need not be the same as the direction. Means not necessarily must be the same. Can be same, can be different. Understand? So it's not fixed one. First one, different. Okay. Orbital period. For this one, 24 hours. This one can be shorter, can be longer than 24 hours. Okay. Different already. Then position, I see. For geostationary, the position is above the same geographical location. Same position. This one, above different geographical location. Location 不一样的。And function, okay, function 它的功用就最大的不一样。你看 for this one is communication satellite. Communication mean for handphone communication this kind of thing So the position must be fixed one. Okay. But for non-geostationary satellite, I told you, right? Earth imaging. That's why I told you take pictures of the Earth one, isn't it? See, Earth imaging. You want to take pictures. You want to take pictures, you cannot have fixed at one position. You need to take Malaysia one. After that, you go and take China one. After that, you go and take England one, right? You need to move around. Okay, that's why the function is different now. Of imaging, I see GBS also. This is more important, Global positioning system. GBS is very important one, Okay. Especially that GPS is important, especially for the aeroplane and for the ship sailing in the sea. They want to go like aeroplane Aeroplane, when you fly up into the sky already, you want to go to Japan, for example, you cannot see already how to go to Japan. So they use GPS, okay, to find the position. That's very important using GPS. And weather forecast. So meaning that you see, actually non-geostationary satellite are more function, taking pictures, taking image of the Earth for GPS, okay, for weather forecast, more function, Whereas these are stationary one, only one function for communication only, for handphone, okay. And last example, this one Miasat. Miasat, Miasat, this satellite is the first satellite of our country. You know which company own this? You know or not? Miasat is,
And
no.
TV1, TV1.
No.
Astro.
Yeah, Extro, Maxis. Okay. Maxis Extro lah. First handphone in our country using Maxis one So this is the first one, no? Miasat. Then later on you have Tiong-sat, Rasat, Sat, Pipit, ISS, and so on. All these names, just a name only, okay? The names of all these are non-geostationary. Okay? This one, okay, So remember the name, Tiong-sat. Okay? This one is owned by Telecom One, okay? Razak Sat used to follow the names of Tunatu Razak now. Pipit ISS. Okay? International Space Station. ISS. These are not Malaysia one, it's other country one. International Space Station, Malaysia don't have even one, Only, I think so far now, only two countries got only US and China. China just put up one only last week. You know the news or not? They use a rocket send this space station into the land, then the rocket come back. Out of control, the rocket come back, then crash into the sea, nothing happened. No? Very good. Last week only happened. Okay, okay, now 2 minutes. Memorize the differences between geostationary satellite and non-geostationary satellite. Okay, 3 minutes, memorize, memorize the direction, the period, the orbital period, the position, the function, and the example. Okay. Focus, wait, please focus. One more minute, huh? Okay, time's up. Okay, right now I want to call this Ethan. Ethan, are you there?
Yes, sir.
Ethan, okay, come. Can you tell me one difference between geostationary and non-geostationary satellite? Just any one, one difference. Just tell me one difference.
The direction of the geostationary satellite is
The direction different, right? How the direction different?
geostationary satellite is
Follow the Earth, right?
and non-geostationary need not to.
Yes, correct. Need not follow the Earth lah. Okay, thank you, Ethan. So remember now, the direction different, one follow the Earth, one may not follow the Earth one, okay? Okay, next one. Gainina. Gainina, can you come up, please? Where are you, Gainina? One more difference, Gainina. Can you tell me one more difference between the two types of satellite? Yes, Gainina?
The geostationary satellite is for communication satellite.
For communication. Whereas the other one, non-geostationary, right?
GPS.
For GPS. And one more for what? Besides GPS is also used for what?
Earth imaging.
Earth imaging. Image take pictures of the Earth. Okay, thank you. Okay, next one. Francis. Francis, can you come up, please? Francis. Francis, where are you? Francis.
Yes, sir. Yes, sir.
Francis. Okay, come on. One more difference between the two. Can you tell me? One more.
Period.
Period. How the period different? How the period different?
Geostationary satellite is 24 hours.
Yes, correct. Whereas?
Non-geostationary satellite is shorter or longer than 24 hours.
Yes, correct. Thank you, Francis. Okay. All right. Next one. Next one. Chin Yi Fan. Chin Yi Fan, can you come out, please? Chin Yi Hong, Chin Yi Fan. Okay, Chin Yi Fan, come out, please. Chin Yi Fan. Where are you, Chin Yi Fan? Not there. Chin Yi Fan. 跑去哪里了你Chin Yi Fan? Okay, Chan Wan Yi. Chan Wan Yi, can you come out, please? Chan Wan Yi. Chan Wan Yi, where are you? Also not around.
Yes.
Why all these people when I call they are not? Chan Wan Yi, are you there?
Yes.
Chan Wan Yi, can you tell me one more difference between the two types of satellite? One more difference just say that anyone.
The position of the geostationary satellite
The position is
is above the location, while the
one is same position, another one
different.
the position can be different now. Okay, thank you, Chan Wan Yi. All right. I think enough already. You all spend some time to memorize it now. Okay, all this geostationary, non-geostationary. Okay, now we look at more things. Okay, more important thing to learn now. Okay, now is this one, escape velocity. There's another thing you need to learn, very important tonight. Escape velocity. Okay, I tell you what. Escape velocity means, for example, you want to launch the rocket to bring the satellite out from the atmosphere. Out from the atmosphere, So you must have enough of speed. Then only you can go out from the gravity. So the minimum velocity required from you escape from the gravity is called escape velocity. Okay, please highlight here. Escape velocity, you see the word escape. Escape means escape from where? From the gravity, understand? Escape velocity is a minimum velocity needed by an object on the surface of the Earth to overcome the gravitational force and escape to outer space. 你要去太空，你就要逃脱这个地心吸力。所以你要离开那个地心吸力到太空，对吗？你一定要有最低限度那个速度。So this is called escape velocity. Okay? So memorize it 抄下来背起来escape velocity is a minimum velocity needed by an object. Object here mainly 是 refer to rocket on surface of the Earth to overcome the gravitational force, to overcome the gravity, and then escape to outer space, 要去到太空。When you want to go to outer space, you must escape from the gravity, the gravitational force. Okay, there's a minimum speed now. You need to be very, very fast. Then only you can escape from the gravity. Then only you can go to the outer space. For example, you want to put this satellite, you want to put the satellite in the outer space. Then you need to carry the satellite, go very fast one, go up into the sky. That's why Malaysia never have the ability to do it. In fact, all the satellite like Miasat, Tiong-sat, Rasak-sat, all these not us one, we pay money, ask somebody else to make for us, somebody else to launch for us one. So actually we don't have the ability to build, we don't have the ability to launch it up into the space. Okay? Yeah. Okay, next one. When the escape velocity is achieved, so what happened? when the minimum kinetic energy of an object able to overcome the gravitational potential energy. This is the meaning now. When the escape velocity is achieved, meaning that your minimum kinetic energy, that move must overcome the gravitational potential energy. So you have two energy here. One is a kinetic, one is a gravity force. Is called gravitational potential energy. So one go up, one come down, one, okay, opposite direction. Okay. Okay, this one you memorize. Okay, now we look at here. Derive the formula for escape velocity. Say you are swallowing like a formula. This is off. No. This is an object or rocket or whatever thing now. So you need the velocity to go up. So the velocity here, you see, there are two important formula. Kinetic energy is half mv squared. Half times mass times square of the speed. Okay? Half mv squared. Whereas the gravitational potential energy 就是 negative 的 because kinetic energy go this direction, gravity potential energy come this direction, so negative lah. Negative g mm over r, no square one, r only. Okay? No R1 remember the two formula, 这两个 formula 不是什么，是原本都有的Kinetic energy half mv squared. Gravitational potential is negative g big M small m over r. R is the radius lah. Okay. You can see from here lah. Okay, this is the kinetic energy. This is the gravitational energy, potential energy. Opposite direction, you put negative lah. Okay, so these two formula, you equal them. Then what happened? You have the new formula come out. 每次这样又出多一个 formula 出来。你看 ，from this kinetic energy equal to the gravitational potential. Okay, so you put them equal because they are negative. One positive plus one negative equal to 0. Correct not? Okay, because same one go up, one come down. So add up must equal to 0 lah. Because one positive, one negative So you solve this equation, then you get this formula. Okay, from here, this one you don't need to know already lah. You just remember this. Square root 2gm over r. If linear speed, right? No 2 1. Square root gm over r. If escape velocity, you put a 2 here. 只是加个2罢了。你看 just now one linear speed. This is a linear speed. This is a escape velocity. You add a 2 inside. 加一个2在那边。This is linear speed linear speed. 这个是 escape velocity. 要逃脱地心引力的速度。Square root 2gm over r. Okay? So memorize the formula, please. This one enough already. Escape velocity formula. V equal to square root 2gm over r. Okay? Now calculate the answer. Calculate the escape velocity from the Earth, the mass of the Earth, this one. Radius of the Earth is this one. Okay. You want to escape from the Earth 你要离开这个地球的地心吸力，你需要的速度多少？叫你算。So using this formula to calculate log. Okay. The formula you have to write now. Escape velocity V equal to square root 2gm. 2g constant g value, the mass of the Earth, and the radius of the Earth 6.3710 to the power of 6. Okay? And then you get this answer. You see, this answer is very, very, very big, 1.12 times 10 power 4 meter per second. Meaning that the speed is like this already. 它的速度是要，如果你写出来你看the speed is 112 like this. Okay, power of 4 meter per second. I mean very fast, 1 second you must go 11,200 meters. This kind of speed only you can escape from the gravity. Minimum 11,200 meters per second. Power of 4就是后推4个位 1, 2, 3, 4. Okay, 11,200. Remember the speed 这个速度你要背住，你知道吗？ You want to fly to the outer space 你要飞去太空，对吗？你的速度一定要这么快。Okay, aeroplane can or not? Aeroplane can get this speed or not? You know or not? Do you know what is the speed of the aeroplane? When you are taking a flight, sometimes the pilot will announce the speed, isn't it? How fast the aeroplane travel. Can the aeroplane achieve this speed? Can or not?
No.
No. Aeroplane usually is the fastest the aeroplane can go is 800 kilometer per hour. If you change this one to meter per second, what is the answer? You can change, you see. Aeroplane is 800 kilometer, but very fast also, 800 kilometer, you add 3 more 0, divide by hour, 1 hour, 3,600 seconds, isn't it? So what answer you get?
222.22.
Only 200 something only. Hello, still very, very far from this speed. Aeroplane no way can escape from the gravity, I tell you. Cannot. Aeroplane too slow. Usually aeroplanes like 737, the speed they can fly only 400, 500 kilometer per hour one. No. This one 800 kilometer per hour is the highest rank of the aeroplane.
Not 1,000 something, mate.
Not
1,000 something.
That one is a fighter jet. That one is for fighter. That one for army use one. No 1,000 something the speed the aeroplane. That one is for fighter jet. Fighter for army to use one. Okay. So this one you know my most important. You all remember this. This is the speed you have to achieve when you want to escape from the gravity. When you want to leave the Earth, go to the moon, go to the outer space, you must have 11,200 meters per second. Minimum speed. Okay? This why you can imagine the rocket, how fast a rocket fly, Okay? When you just launch it, never go very fast, Then it's getting faster and faster. I want to carry the satellite go up into the sky. It's very fast one. The rocket. Okay. All right. This one finished already. Copy the answer already, everyone. Okay. Come, we move to the next one. Next one is this one. Okay. Factor affecting the escape velocity. So the factor affecting, you look at the formula. What is inside the formula? Okay. Square root 2 gm over r. So two things only. The mass of the Earth and the distance of the object from the center of Earth. These two things because the formula square root 2 g. G is a constant, no effect one. This one got effect. The mass law and the distance, the radius, okay? 2g, no. So the one affecting the escape velocity is the mass of the Earth and the radius, the distance from the center of the Earth. Okay, remember now? Okay, benefit and implications of escape velocity. What benefit you have? Why the Earth can maintain some layers of atmosphere around it? Mass of Earth is not fixed already. Now can it affect escape velocity? Okay, we say like this now. Who asked the question just now? Brandon. Okay, actually this formula is not to find the escape velocity from the Earth, you know. It can be find the escape velocity from the moon. When the rocket go to the moon, landed in the moon already, right? You want to come back, ma? So you want to come back means you also need to escape from the moon one, you know. So when referring to the moon, right? So this one become the mass of the moon, no? That's why the mass is important now. Brendan, understand now? Can be any planet. This G big G is same. But the mass can be the mass of the moon, can be the mass of the planet. When you, let's say you send a rocket to the Mars, after finish your research already, the rocket want to come back, want to leave the gravity from the Mars, isn't it? And then the mass of the Mars is important. Okay? Okay, benefit and implication are escape. So why the Earth can maintain some layers of atmosphere around? You see, high escape velocity of Earth, 11,200 meters per second. Molecule in the atmosphere move at average linear speed 500 meters per second only. The molecule of the Earth, the gas law, that is lower than the escape velocity. So they cannot run away. So a molecule are not moving randomly, will not be able to escape from the Earth into the outer space. This is the advantage of big escape velocity. You want to escape from the Earth, you must achieve 11,200. But unfortunately, all the gas molecule, when they move far, they fly around, right? They cannot achieve this kind of speed. This is the reason why they cannot live. They always hold by the gravity. So this form the atmosphere. Actually, the formation of atmosphere also because of this gravity, you know. The gas molecule are not able to escape because we cannot achieve that kind of speed. That's the advantage. Okay, copy the answer, please. Okay, next one. Why the commercial aircraft cannot escape into the outer space there? Very easy, because the speed lower, right? That's the reason. Okay, now copy the answer. Commercial aircraft, for example, like 737, 747, or this fly at linear speed 250 meters per second. Our calculations are 200 something, right? Okay, can how you see? 250 meters per second only, you know, commercial aircraft. While fighter jet can achieve supersonic linear 2,200. This one is for fighter jet. both their linear speeds are lower than the escape velocity, so they cannot go to the outer space. Even the fighter jet also cannot. Only rocket can. Rocket, because the explosion, the speed very fast one, you know. Okay, so normal aircraft cannot, the fighter jet also cannot. So they cannot go to the outer space. They can only fly in the atmosphere. Okay, next. How can a rocket achieve escape velocity? I see rocket, I told you can, right? The launchings of rocket require large quantities of fuel to produce a high thrust that enable the rocket to achieve escape velocity of the Earth. Hence, it can send the spacecraft to the outer space. A rocket cannot. Rocket very, very fast. You know, rocket is very powerful. One rocket now can more powerful than 100 737. Can you imagine how powerful or not? One rocket now, when it explodes, the gas come out, is the power equal to 100 aeroplane. 相等于100辆飞机的力，你知道吗？ That's why you can fly very fast, the rocket. Okay. Okay, finish or not? Chan Jiming, finish, copy or not? Chan Jiming. Chia Jia Yi, finish or not? Chia Jia Yi.
Not yet.
Not yet. Okay, okay. Take 1 more minute. Done or not? Alicia, have you finished copy, Alicia?
Yes, teacher.
Finish, Christine, finish or not?
Yes.
Finish, Harish, finish, Harish, Ian Run, finish,
Yes.
Okay, finish, Vinny, finish or not? Vinny and Joel. Justin, have you finished? Justin?
Last sentence.
Okay, last sentence. Okay, good. Joel, Vinny, finish. Okay, come now. Okay, Okay, next one. Solve problem involving escape velocity. We want to find the escape velocity. Okay, example. Venus, the Mars given the mass, Jupiter, the radius all given. So use this formula, right? 2gm over r. So you put the m and the r over this one, g same lah. So you get this answer. This answer, never mind, you don't need to count lah. You know this formula can already. So you get this answer. To escape from Venus, you need very fast also. Mars and Jupiter, you want to escape from Jupiter, you need 60,216.6 meter per second. Very hard to escape, you know. You want to escape from Jupiter, very hard. Okay. Okay, next one. The moon and the sun. This is the moon, this is the sun. Okay, you want to escape from the moon and the sun. When you do the calculation, this one I want you all to calculate. This one calculate, you all can calculate or not? Put the answer here, lor. Okay, now mind we look at this question slowly. This is the mass of the moon, the radius of the moon. This is the sun. This is the radius of the sun. Now the question like this. Compare the gravitational acceleration on the moon and on the sun. This one you know lah, or then the escape velocity from the moon and from the sun. So we need to do the calculation lah. Okay. But we use our common sense also. We agak know already lah. The gravitational acceleration on the moon and on the sun. Who is bigger? Who is smaller? Gravitational acceleration means the gravity on the moon is 1 point something, correct? Not on the sun is very big now. The other day we count already. Okay. Now escape velocity. Okay, come. Now copy down this answer. Use this formula to find the gravitational acceleration. Gm/r squared. Big G. This is the mass of the moon. The radius of the moon square, then you get 1.62. That's why the gravity on the moon is only 1 point something. The gravity on the sun, very big now, 274. So same formula now. G, the mass of the sun divided by radius of the sun, you get this value. So, but no, the moon, the moon gravity very small, but the sun gravity is very big, you know. Okay, now can you all use the values of all these things? Calculate the escape velocity of the moon and the escape velocity of the sun. Okay, can you do it? Everyone do? Use this formula. 2gm/r. You find the moon, you take the mass of the moon divided by the radius of the moon given on the left side just now. You want to find the escape of the sun, escape velocity of the sun, you put the mass of the sun over the radius of the sun. Okay, please do it now. Give me the answer, please. This one I want you all to do yourself. I don't want to let you copy. Okay. Anyone got the answer for escape velocity for the moon, escape velocity from the sun? So share your answer, please. God, I see someone got the answer already. Tan Kian Hao, wow, very fast. So he got the answer. Moon and the sun. Tan Kian Hao, can you share your answer so that everybody see your answer? Can or not? Don't direct message, okay? For everyone, please. Any more answer? Any more student give answer? So far, I have answer from Tan Kian Hao, one student only. Other student? I wait for one more student give, please. Okay, any more? One more student give answer, please. Lai Wei Ho. 5.635 10 power negative 3. Wei Ho, your answer different, you know. Ng Tiam Sun 0.07. Different answer, no? All this. Francis same 0.075. Now I see Tiam Sun and Francis are answer same. Kian Hao answer different, you know. Kian Hao and Lai Wei Ho, the numbers.
Teacher, I forget to square root already.
Yes, no. Okay, so what is the final answer then after you square root?
Also the same. It's different. I come out.
The answer same is what? 0.0751.
Teacher, my whole thing count already. Wait.
Okay. 江七 also same. I also forgot the square root. Like the square root is so big, don't forget, no. Don't forget the square root. So I think the answer will be 0.0751. I think so many of you got the answer. Okay, come you check your answer now. Okay. No, not 0 point something there, you see. For the moon, 2.3710 power 3. I don't know this answer correct one or not. 2G.
So
Huh?
the
Teacher,
radius is 10
your
power,
one
10 power
is
of 5
10 to
or 10 power of
12.
6. So
Which one?
the radius of moon.
Moon. Okay, now let's see here. Radius of the moon is power 6.
Teacher, our mass is 12.
Huh?
Teacher, the mass
Mass
Look
of
like
who?
5.
the mass is 12, but your answer is 22.
Yeah, I think here is wrong. It should be power 22, not 12. Sorry, 22. Mass of the moon is power 22. I can remember it's power 22, not power 12. Sorry, just now I didn't remind you all. Do I think you got the answer? Answer like I showed just now. The mass of the moon is 10 power 22. Okay. Okay, thank you. Luai, very good. It's power 22. This one mass of the sun is correct. Power 30 is correct. Okay. So the answer should be like this lah. Okay. 2gm. This is mass of the moon. This is the radius of the moon. And this is sun. the mass of the sun, the radius of the sun. So you get this answer lah. Okay, check again so that you get this answer, you know. Brendan, you got the answer or not, Brendan? Both also same lah, the moon and the sun. You got exactly the same, Brendan? It's very important. That's why the number are very big. That's why you have to practice using your calculation. I want to write to my friend. Cassandra lah. Actually, the mass of the moon, the actual one is 10 power 22, not 12. It's 10 power. This one is correct. Power 22 is correct. Cassandra, I make correction just now. Maybe you didn't realize. The mass of the moon is 10 to the power 22. Not here. Not easy. It's 10 power 22. This is the mass of the moon. The mass of the sun, power 30 is correct lah. Okay, this is not 12, it's power 22. Cassandra, understand? Okay, understand? It's power 22. The sun is power 30. So these two answers are correct now. Some I think got student get the same answer, correct? Not Brendan, you got exactly the same. These two answers. Okay. Thank you, Brendan. Mean the answer correct lah. Okay, thank you, Brendan. And also the conclusion we have to write down. The moon has low gravitational acceleration, 1.62 only, and escape velocity also small, because 2000 something only, 2.3710 to the power 3, because the mass of the moon is smaller than the sun. Okay, the gravitational acceleration of the moon is small, and even the escape velocity also small, is because the mass of the moon is small. Okay, the sun is the largest body in the solar system. Gravitational acceleration of the sun and the escape velocity from the sun have the highest value compared to those of the moon as well as other planets. So meaning that to escape from the sun is the most difficult. The reason is simple because the sun has a biggest mass. The mass biggest, so the escape velocity is very, very big. So basically, I think very hard to escape from the sun one, because the escape velocity required is very, very high. Okay, finish or not? Okay, I finished one more question, then I stop now, huh?
Haven't, teacher. Can you give 1 more minute? Haven't copy finish.
Okay, okay, okay. Okay. One more question I want to go. Question number 3. Escape velocity from the Earth for the spacecraft X of mass 1005 is different from the spacecraft Y. Okay. When you look at the formula, the escape velocity, the mass is the mass of the Earth, So it's nothing to do with the mass of the spacecraft X or Y1. That's why the answer is escape velocity from the Earth of both spacecraft should be the same. Mass of the satellite does not affect, not effect, affect. This one spelling change, affect. Does not affect the escape velocity, okay? Because to find the escape velocity of the spacecraft X, spacecraft Y, we are using the mass of the Earth, not the mass of the spacecraft. That's why the answer is the same now. Okay? When you want to escape from the Earth, you take the mass of the Earth. When you want to escape from the Moon, you take the mass of the Moon. When you want to escape from the Uranus, you take the mass of the Uranus, like that one. Not the mass of the object. Okay, understand now? Question number 3. So far, can understand or not? So I stop here for tonight. So for this week, I will stop 9:15. I stop now. Hari Raya. This is Hari Raya week. Okay. Li Pei Xin, have you finished or not? Pei Xin?
Yes.
All finished already. Number 3 also finished. Pei Xin.
Yes.
Okay, good now. Li Chen Yang finish or not?
Finish.
Finish. Now I ask this Kian Hao. Kian Hao finish already. Just now you say.
Yes, just now finish only.
Okay lah, finish already lah. Everyone finish. So finish. I stop here for today lah. I don't want to take so long like you're online. Too long, very boring. Okay, so I stop sharing the paper with you all now. Okay. So that's all for tonight, huh? Okay. So that you wouldn't feel too tired. Okay. So remember, everybody must take good care of yourself. Don't go anywhere. You won't go anywhere, you make sure you wear a mask. Understand? That's very important. No, huh? Wear a mask. Okay. If possible, don't go any place already. Now cannot go out makan already. So no need go out already. Jalan-jalan also cannot already. Makan also cannot. So stay home, stay safe, everybody. Okay. So see you again next week. Okay. Bye-bye, everyone. Bye-bye. Okay. Bye-bye,
Thank you,
everyone.
sir.
Thank you,
Bye-bye.
sir. Thank you,
Bye-bye.
sir.
Okay. Bye-bye. Bye-bye.
Thank you, sir.
Okay. Bye-bye. Okay. Bye, everyone. Okay. Bye-bye.